So basically, ladies and gentlemen, what we have talked about so far is understanding, what you guys, in preparing for your test, we've dealt with, factoring and solving for, and we talked about solving by factoring out the GCF, factoring trinomials when a is equal to 1, as well as solving by factoring when a is not equal to 1, which we did last class period. There is going to come a case, though, that if you cannot factor a problem, or you simply, the problem is not factorable, or you're just having problems factoring and you want to check your answer, there is another way that we can go ahead and use for solve, or to solve our equation. So remember, guys, what we did last class period is determine what your a times c is, in this case, right? Or determine what your determine what two numbers multiply to give you 18. Multiply to give you 18, but add to give you negative 5. And if you guys look at the factors for 18 times 1, 9 times 2, 6 times 3. And what you guys notice is none of them are going to be able to add up to give us negative 5. Correct? So therefore, we would not be able to factor this. However, we can still find the solutions. All right? And to do that, what we're going to use is the quadratic formula. But when applying the quadratic formula, we're going to do things in certain steps. All right? So I'm going to break them down and work with you guys on each step. The first step, which I think is the easiest to do, is to identify what is your A, B, and your C. All right? And you're simply just going to look into and identify what is the values of A, B, and C. Now remember, where A, B, and C come from is our standard form of a quadratic, which is y equals ax squared plus bx plus c, where A is your coefficient of your quadratic variable, B is the coefficient of your linear variable, and C is going to be your constant. So now A is equal to 6, B is equal to negative 5, and C is equal to 3. So that's step 1. Is everybody OK with step 1? Yeah. OK. Now let's get into step 2, which is identifying the discriminants. So basically, the discriminant is b squared minus 4 times a times c. So all you guys are going to do is you're going to take the values that you just found, or the a, b, and c, and you're going to plug them into that formula. So you have negative 5 squared minus 4 times 6 times 3. Does everybody see that? OK. Kind of like what we did last class. Well, I don't know what we do last class.
Okay, you're a teacher. You don't know your information.
Well, no. In last class, we dealt with. Last class period, we did factoring, the AC, but we did this. But we're not factoring. We're going to use an equation to solve. So now I need to do 4 times 6, which is 24, and then times 3, which is going to be 72. Then, now what we simply need to do, Dave, please don't talk. Now what we're going to do is we need to subtract them. And when you guys get this, you guys can see when I subtract, I get negative 47. All right? Now, I will go through exactly what we're going to do from here on out. All right? But basically, Walter, what I want you to see is whenever you guys have a negative, you're just going to write no real roots. And again, I'll explain this in a little bit more detail next class period. OK? So now we still need to finish up our problem, though. We have just determined that it's a negative. We've had this conversation before, right, Amy? So now we need to go to our third message, number 3. And on the final one on number 3 is we are going to finish the answer by using the quadratic formula, where the quadratic formula gives us our values of x by using opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now, I will tell you, though, ladies and gentlemen, what is important about using the quadratic formula and what's important about using the discriminant the way we used it is now you have You already know what b squared minus 4 times a times c is, because you already did that when you identified the discriminant. Does that make sense? So what's really important, what I want you guys to understand is the discriminant, this math you guys already did, is under the square root. So now all I'm simply need to do, Amy, is just plug in those values. So opposite of b, right now my b is, that Amy, not you. Opposite of b is going to be a positive 5, plus or minus the square root. We already identified the discriminant, which is negative 47, and divided by 2 times a, which is 12. Because 2 times 6 is 12. Is everybody following me with that?
Yes, sir.
Nick. Please don't talk. That's fine.
So question.
Wait, what would you guys answer?
Well, I don't understand. It's probably a dumb question. But how do you get the plus and the minus thing?
I can explain that, and I'll go off topic not in another video after this, okay? So now we're not finished though. So we want to look into, can we go ahead and simplify our square root of our negative number? And we cannot simplify the square root of 47. But there's another important thing that I want to make sure that you guys have is we can't take the square root of a negative number. And as I remember I wrote in there, no real roots, right? However, we can use the imaginary number system. And just for this class, just so you guys at least have that prepared, we're going to use our imaginary number system here. I have 5 plus or minus the square root of 47. Instead of writing negative 47, I'm just going to write in, well, anytime you're taking the square root of a negative number, you're going to be using our imaginary number system, which is I. Guys, it's really, really distracting when I have to keep on hearing people that are laughing. It really gets distracting. So if you guys can just hold that off until you have the opportunity, I'd greatly appreciate it. Now, you have, then we divide our 12 into both of these terms. OK? Yes? Yeah.